Now, when you take a derivative, you are not going to want to go through the limit process and finding the slopes of the secant lines and then taking the limit of those secant lines into a tangent line. That takes way too long. So we're going to develop rules or shortcuts to do that for us. The first rule that we talk about is the constant rule. So if you differentiate something that has nothing to do with x, right? If that k is not a function of x, if we were to graph it, k would always be just something for any x value. Then the derivative is going to be 0. So any tangent line that you draw here, the slope is going to be 0. K doesn't change as x changes. The second rule that we talk about, and this is by far the most important derivative rule, is the power rule, which tells me how to differentiate a variable x with respect to that x value. So it's important that if you are differentiating with respect to x, and the x is up there in the exponent, that is not this rule. You are differentiating with respect to x, the x variable raised to some constant. The rule tells me that I can take this n value and I can put it out in front of the x value. That new power on x is now dropped by 1. So for instance, if we had x to the 5th, and we were differentiating with respect to x, notice I'm differentiating with respect to x, and I've got x raised to some power. So the power rule tells me that the 5 is going to come down in front. The new power is 5 minus 1, or 4. Like x to the 8th, oops, that's not an 8. X to the 8th, when differentiated with respect to x, yields 8x to the 7th. So let's see two applications here, or at least two examples. On the left, we have a function that's constant. Y is constantly equal to 3. So how does this function change as x changes? 0. For any value here, 3 does not change as x changes. Here we have a power rule, x cubed. And the power rule tells me 3 comes down, and the new power is 3 minus 1, or 2. So 3x squared. If I go over here and look at this x value, then the value of this function is given to me by the function value, x cubed. But the slope of the function at that point is given to me by the value of the derivative, 3x squared.